Yeah, here's a meme. This is basically you while debugging. Everything may be on fire, but as long as you can kind of keep yourself like calm and get through it, you're going to be okay. So this is a quote from a professor of CS at U of I, Wade, and I cannot pronounce his last name, but Wade is just a great CS professor. And so this is a quote from him: "Debugging sucks. I hate it. Tools, IDs, debuggers, etc. all make it easier, but it still sucks. And finding a bug can take hours just to fix one line of code." And he tries to avoid everything he can to avoid needing to debug. And this is very true. Everyone hates debugging because you can make the simplest of errors and it can take you as much time as writing the rest of it would take. So let's talk first off, before we talk about how to fix bugs, let's talk about how to avoid them. So, with that, there are a couple of different things. So, the first one is writing clear code. The clearer your code is and the clearer it is to read your code, the easier it is for you to debug and for other people to, or for you to avoid bugs and for other people to avoid bugs. Because the more code that's clear and the more documentation you have, it's going to be easier for you to deal with it's going to be easier for you to understand what's going wrong if you make a simple mistake. So the second thing is unit testing. This is something that CS126 covers, so we're not going to cover it too much in depth here. But essentially, unit testing is the idea of creating code to check your code's result against a known result that you've done by hand or some other way have generated. So then abstraction and encapsulation, once again, this is a CS126 concept, but essentially the smaller that you can make your snippets of code, the better you're going to be overall, because if something goes wrong, you have a very clear, easy way to debug, because all you have to do is just check, okay, well, this function, if I assume it's good, am I doing anything wrong here? Okay, well, it must be the sublevel function, and so on and so forth. It makes it very easy to debug. Then finally, on this side anyway, there's tweak and run, which is a method that I'm coining, which is essentially to literally write like one line of code, add it like new, and then run, build, run, whatever, just check and see what happens, right? The more that you do this, the smaller the chances of you making a bug are, because you're only making very small incremental changes, so you're not going to make a large amount of bugs and then think you cleared all of them out, but miss one in actuality. And this goes for Git as well. When it comes to tweak and run, the more small commits you're making, the better. So that being said, there's more. Pair programming, great way to debug or to avoid bugs. Okay, pair programming is where you work with someone else. Usually, there's a bit of a experience like gap between the two people pair programming, but it can also be a peer. So pair programming can be like, say, a senior engineer and a junior engineer, or it can be two students, whatever it is. And in that case, you're going to most likely be dealing with bugs like, because only one person's typing, the other person can kind of watch over your shoulder, and then when you make an obvious mistake, you'll very easily catch it. So the second thing is, or the, what are we on? 4 plus 2, sixth thing is proper Git usage. I alluded to this a little bit above, but the more commits that you have, the easier it is to revert back to a lower level. I will answer the question in lecture questions later, probably after lecture. Um, so yeah, proper Git usage is basically just like the smaller the commits you make, the easier it is for you to revert back to them if it turns out that a like commit you made like was wrong. So if you use Git correctly, it's going to be much easier to avoid bugs. And then the final thing is code reviews. So this is essentially a similar thing to pair programming, but instead of actually having someone sitting there with you the entire time, which costs a lot of money and is just generally time consuming, code reviews are the concept of basically having someone else look through your code after you've finished, and then they can check for bugs as they're going along, and they'll just notice a lot of obvious things. And that's another example where someone more experienced will typically be doing that, because that way that person will sort of catch some of the things that are a little bit more nuanced that someone more junior might not. So yeah, those are all the ways to, or at least those are a lot of ways to avoid bugs. Um, but unfortunately, there aren't any foolproof ways, at least as of yet, to avoid bugs 100%. So, can we make debugging itself less painful than that quote at the start of the lecture? Well, it depends. So this is a famous example of a bug, and so this is a cartoon, but essentially there was a NASA satellite that, because there was a conversion from meters to feet, ended up crashing into Mars because it was using the wrong units or something. Basically, the point being, super simple bug, super easy to fix. Nobody noticed it because they weren't thinking about every single little detail, and these kinds of bugs do catch through. And so this is a really good way or example of why you should try and avoid bugs when you can, but if you can't avoid bugs, to try and fix them before you have something as catastrophic as this. So this is a really like interesting statement that I have. If you consider yourself like a doctor, a bug is like cancer, right? The earlier that you catch it, the easier it is to solve it and to sort of treat the problem. But as you build into a project, the longer it goes on, the worse it's going to get. Because if you build something, it's going to have a lot of knock-on effects when you fix the bug. And so to visualize that, we're going to take a look at this slide. So let's say I write some buggy code at the core of whatever app I'm making. And then I add a helper function that uses that buggy code. It makes a call, and then I do some adjustment because I noticed that the values weren't quite right, and I fix it, right? Then maybe I write a driver function that takes that buggy code and puts it into some sort of application. I write a basic application so that a user can interact with my code. I even write an important class that builds this idea of state around the code. I link these functions and classes up. I even develop a developer API, right? All of this code is now based on buggy code that's wrong. And so now either these applications are going back and fixing the mistake on their own, or they're just outputting wrong values. So this code, now that it's grown to this level, if we find the bug and we now need to fix it, it makes all the rest of this code potentially invalid, which is very bad. So this is something that you want to try and avoid, and this is why you want to make sure that your code is as bug-free as possible whenever you're writing it initially. So we've talked about sort of why debug and how to avoid debugging, but now let's talk about how we actually debug. And to do that, we have to talk about where bugs come from. And it typically comes from when you make an assumption about your code that isn't true. So a really good example of this is I was doing some work, and once I made a mistake where I was accidentally deleting something twice. Now, the assumption was that when I wrote the code, I was actually deleting each thing once, but instead I was deleting one thing twice and leaving one thing alive the second time. And this led to a lot of issues. So this is a really good example of sort of where you make an assumption that doesn't actually turn out to be true and comes back to become a massive bug for you to have to deal with. So let's talk about the tools to debug and how we actually debug now. So when it comes to debugging, you can have multiple different tools to debug your code. And just like in real life, using the wrong tool can actually do more harm than good, right? You don't want to be using a hammer to screw in a like Phillips screw, right? That just doesn't work. So instead, you want to be using the right tool for the right job. So let's talk about the first tool, which is print debugging. So it's using print statements to determine what your code is doing at runtime. And so it can answer a bunch of different questions, such as, do I ever reach this print statement? Why am I getting a null pointer exception here? How big is this array? How many times does this loop execute? Those are all the questions that you can get by print line debugging. And so these are all super useful, and it's a really great way, especially for beginners who don't have access to a lot of other things, to get your best to get like the best results from your debugging, like when you're on a restricted environment. So the best example for this is like if you're deploying something to a server and you notice something isn't working, you're typically going to just print debug because you don't have a fully fledged IDE just lying around on your server. So let's give a quick demo about print debugging. So here's some code, all right? This is a simple loop here. And so what I do is I say this number of times I want to loop over it, and then I want to return the sum of that. So let's run it. And I think that's loop.py. There we go. So now you can see 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 2, or 1 plus, what's going on? Oh, I see what's going on. I have a print statement in here from when I was debugging this. Okay, there we go. So now you can see when we get the number of, we get the sum of 0 to 5 as a int printed out. So this works great, right? No problems. We are good here. No, unfortunately not. So this has a bug in it, and to show that, I'm going to do -5 instead of 5, right? And if I do that, you're going to see it's just going to kind of hang, right? If I start typing, it's going to type, but I can't actually enter new commands, right? Like if I say exit, nothing's happening. So I have to kill the program, which is obviously very bad. So instead, let's take a look at how we can fix this, or take a look at what's going wrong by doing print statements. So in this case, what we're going to do is we're going to go in here and we're going to say print I, right? We want to see what I is. And if we run this now, you'll see it's going essentially off to infinity. But you're going to kind of see, why is this happening, right? So let's kind of look at this, right? So it's continuing to go up. And so we know that it's going up because, like, if you look, it goes from 537 to 8 to 9 to 40 and so on. So what you have to do is you have to say, okay, why am I incrementing +1? Okay, there it is. Is that the correct thing to be doing, right? If I start at 0, do I really want to be incrementing by 1? So in this case, if we look at the sort of number that we pass in, right? If we start at 0 and we keep adding 1, we're going to continue to go to infinity because we've already passed that point of -5. So instead, what we need to do is come up with some sort of solution to that. And so the easiest way to do that would be if I is less than times, then we want to increment. And then otherwise, or else, we want to do I minus equals 1. And so now, if we try and rerun that, you're going to see it's going to print out the sum to the negative number. But if we print out the positive number again, if we change that back to +5, well, we have another bug. That was actually not expected, but I'm not surprised. So yeah, this is sort of the battle of bugs that you can kind of get, is where you're perpetually going to run into this issue. I think I can fix that with an equal sign. Yeah, there we go. So now you can see we fixed that bug. And so this is just kind of a thing that you have to work on, is sort of this intuition about it, as well as the idea of printing things out and just kind of playing around with it. And so somebody asked, would a try except be better or worse in this case? So in this case, a if else is probably going to be better. And so the reason for that is that we don't know what times is going to be. And try except is great, except when the except case runs. So try except is very fast on the try case because it will try to do something. But if it fails, it's going to be very, very slow, and it's going to take a lot of time to catch up. Whereas an if statement is about 50-50. It's going to run the same speed, but it's going to be slower. So it's sort of in the middle of that. In terms of when you use those, I would say usually use an if else. If you know something is like going to work like 90% of the time, that's when you use a try except. So yeah, that's like sort of a basic print debugging example. But so we're going to actually comment this code out. And instead, we're going to put that back I plus equals 1. And then, yeah, it should be everything. Yeah. Okay. So let's talk about the cons of print debugging, because there are some things about print debugging that just aren't great. And so one of the biggest ones is that you're making many changes to your code, right? You saw there, like I was putting a print up here, I had to put prints down here. There are a lot of changes that are happening. And every time you need to recompile it, you need to rerun it, which on a larger code base can be a very big issue. and it takes time, and as I said, can be problematic. They're part of the code, so it changes the line number. This is really important when you're doing something like pair programming, especially nowadays, right? If I sent this repository over to, say, Welby, and I asked Welby, hey, look at line 6, right? But then I added a print statement um, to line 5 or to line 6, then now our lines are going to be different. And when we reference things, we're going to have different answers. So that's going to be a really important issue if you're collaborating. And it leads to what I like to call code appendix syndrome. So going back to us being code doctors, the appendix, at least as far as I know, is a useless organ. And as a result, it just kind of sits in your like body. You don't really have like a real good reason for it. The same thing happens with debugging print statements. You'll just kind of leave them in there because it's like, oh, well, if I ever need to debug this issue again, I can just uncomment my print statement. And so it leads to a bunch of dead code that you're never really using, or even worse, you may just not comment it out, and now the user is going to get a bunch of print statements whenever they run your program, which is obviously pretty bad. So those are like the two main reasons, but it also leads to limited scope and abilities, right? So you can only do so much with print statements, and there are much more powerful ways to debug. So let's talk about rubber duck debugging. And this was sort of the quintessential way to debug for a while because it's this idea of using a friend. It's got a very wholesome message to it. So the name is a reference to a story in a book called The Pragmatic Programmer. And so a programmer would go around carrying a rubber duck in his backpack and would legitimately just open his backpack, pull it out, and put the duck right on the computer, just like here, and read the code every line by line to explain it to the duck. And usually, in the process of explaining it to the duck, the programmer found out what the issue was. So in that scenario, you cannot just use ducks. You can use all kinds of things. So in this case, we have a Rust plushie, we have an actual rubber duck, and then we have the Android figurine. If you go to the social hour after this lecture, you may see a guest appearance by one of these Android figurines. But point being, there are all kinds of different ways to debug. So if you take a look at Wikipedia, I know this is a really beefy quote, but it's really important. Many programmers have had the experience of explaining a problem to someone else, possibly even to someone who knows nothing about programming, right? And this is really important because then as you're explaining it to someone who knows nothing about programming, they may ask questions, and having to teach and explain that problem or having to teach and explain everything along the way is going to lead you to usually figure out what you did wrong, right? So in this case, any incongruity between these two becomes apparent. And what that means is that you're going to explain something and you're going to explain what you think it does, but then you're going to be reading the line at the same time. And it's going to force you to think, is this doing what I think it's doing? And that typically gets a lot of bugs solved before you even have to do any other debugging. So how to do rubber duck debugging. So you got to get a duck or other inanimate object, your choice, that'll listen to you. And so you want to go line by line and explain what you're doing with a lot of detail. So this should really be like legitimately line by line by line. Okay. And so then eventually, as you're going through line by line, you're going to have a eureka moment. You're going to be like, oh, yes, I found the bug. And you're going to find the mistake and you're going to put the duck away. Or if you did not get an inanimate object, you're going to apologize for bothering someone else when you figure it out for yourself anyway. This has happened to me many times. It's always embarrassing, but the upside is that you did end up solving the bug. So yeah, rubber duck debugging is really cool. It's really useful, and it's just a great way to debug. So let's talk about a rubber duck debugging demo. So let me do one quick thing here. So what we're going to do is we're going to take a look at this loop again. And what we're going to do is we are going to actually bring a guest onto the screen. So let me go grab our guest here. I said we were doing social hour, but instead this guest is coming live. This is when you know we are actually doing this live because I have to go and get something that I forgot before lecture. this is what happens. Okay, so I'm back. So here's our code, right? And so what we're going to do is we're going to ask our friend here, Andy, to help us decode or debug. So what we're going to do is we're going to talk to Andy about what's going wrong. So I'm going to change this back to -5 because that's the case where it goes wrong. So we're going to clear this and we're going to pretend we never saw it before. And as you can see, it's just broken. So we have Andy, and I'm just going to talk to Andy. So, hey, Andy, I have this program that isn't working. So let's talk about what it does. So I have this function called loop, and it takes in a number of times that it's going to run, and it returns an integer. And so in this loop function, I have a variable called I, and that's my index, and that tells me how many times I've run through the loop. And then I have a sum that's counting the sum of all the i's every time I run the loop. So then I say while I is not equal to times plus 1, then I say sum plus equals I, and I plus equals 1. And then I return the sum after this while loop is done. So here's the thing though, when I put in -5, I'm not actually getting 1, right? I'm not actually getting the correct answer. And so one thing that I think it might be is because when I say while I is not equal to times plus 1, oh wait, that's it. Times plus 1, instead of doing not equal to, I want to do less than. And now if we try it, you're going to see we get 0 because now it's not working at all. But in this case, what we can do is say, I didn't say Eureka. Someone caught me on that. So yeah, in this case, let's try and debug this, right? So now in this case, what we can do is we can actually say, so Andy, now it's just putting out 0 because I is going to be less than the number of times every time when it's, or I is going to be greater than the number of times every time. How can I fix this? So I set I to 0 and then I do the sum and so on and so forth. Eureka, I did say it this time. So in this case, what I'm going to do is I'm going to say that if times is less than 0, then I'm going to set times is equal to times -1. Also, that's a really confusing sentence. But so now what I'm going to do here, Andy, is I'm going to say if it's negative, I'm going to convert it to a positive, and then at the end, I'm also going to set a flag here. So is negative equal to false, and then is negative is equal to true. And now at the end, what I'm going to do is I'm going to say is negative, and then if it is negative, I'm going to return a positive or a -1 times sum. And I'm realizing I cannot do ternary operators in Python. If is negative, return -1 times sum, and then otherwise return sum. Okay, so let's try that. And as you can see, now we get -15. And if I put 5 there, we get 15. So Andy helped us solve this because I was able to talk through my solution and what was going wrong. And you can see that because I was able to talk this through, I came upon a completely different solution than I would have the first time when I did a print statement. And so this is what you can find is that there are multiple different ways to solve a problem, and no one may be better than another. It's just kind of a question of, well, which one do you think is better? And so in this case, I would argue that this one's a little bit better because you're not comparing this if every single time you're running the while loop, but that's a personal opinion. So yeah, this is debugging with a rubber duck, or in this case, Andy. Hopefully you had a little bit of fun watching my terrible, terrible acting there. But let's move on to debugging tools. So debugging tools are super, super useful. You should be using these every chance you get and every time you want to use them. And so what they are is this idea of allowing your code to stop execution on a given line that you control, and then to allow you to operate your code from there. So debuggers are incredibly powerful because you can see everything that's going on all the time. And so if you look down here, this is a little bit of a bar that shows us all the different items on a VS Code debugger. So I'm going to give us a little bit of a demo here in slide. So this is some production quality right here. If you want to throw some pogstis or any other emojis in the chat, this is the time. So what we have here is fizzbuzz. And so this is a function that's going to calculate an array for fizzbuzz where if a number is divisible by 3, it's going to say fizz. If it's divisible by 5, it'll be buzz. If it's both, it's going to do fizzbuzz. And then if it's not none of the above, it'll return neither, right? And so we want an array for all of the integers that we have. So now let's take a look at this code and let's see what it gives us. So let's say I'm going to clear the screen here. I'm going to do Python 3 fizzbuzz. And we get fizz, neither, neither, fizz, neither. So what I'm noticing here is that we go up to 5 and we get, or I think I need to go to 15. Yeah, I do. So if I run that again, there we go. So we have a couple of issues here. So the first one is that apparently we're printing this in reverse order, right? So it should be neither, neither, fizz, neither, buzz. So let's fix that. And so what we're going to do there is we're going to do reverse. And now we get none. Hey, Andy, what do you think? I called reverse, but it's not doing anything. We'll get back to how to solve that question later on. In the meantime, I'm just going to do dot reverse because that's the, never mind, that's not the answer. We're just going to pretend that isn't an issue for now. There we go. So as you can see here, we have it in reverse order, but so it goes neither, neither, fizz, neither, buzz for 0, 0, 3, 4, 5, or 0, 1, 2, 3, 4, 5. No, 1, 2, 3, 4, 5. There we go. But if you notice on this last case, 15 is divisible by 3 and 5, but it's returning fizz instead of fizzbuzz. Why is that? Well, I'm not exactly sure. So let's talk about how we can debug this. So what we can do is we can set a breakpoint by clicking on the line and have a red dot there. And that will basically tell Python and VS Code in this case, when you reach this line, stop, start a debugger up, and let me know. So we're going to do that. We're going to start this up, and as you can see, I've got a very fancy debugger in slide, so this is going to be a lot of fun. But so when we start this up, you'll now see that we have our debugger that is running on line vals, and so we now know what vals is, and we're at this line. So now we have these buttons up at the top right. So let's talk about the first one. The first one is the one that I just shook a little bit there. That's that arrow with the dot and the arcing one. So that one is what's called the step over command. And so what that's going to do is it's going to jump to the next line, whichever one that is. So in this case, if I click it, it's going to go down to if length is less than 0 because it executes the vals line and then it's going to go down to the next one. And so if I do it again, length is less than or length is greater than or equal to 0, so it goes on to the next line, and so on. So that's sort of the step over command in a nutshell, and it's a really useful command. It allows you to just kind of move around. But let's say I want to know what's going on in FizzBuzz Helper. This is where we're going to use our second button, and that is the step into command. So that is the one that's shaking right now, the one that's a down arrow with a dot. And so what that is it's telling you, okay, whatever function I'm calling, go and put the debugger in there. So if I hit it, it's going to go down here, and we're going to see that we're at if FizzBuzz Helper is this, right? And so now we can step over, and we know that when it's 5, it works just fine. So now that we know it's not going into 3, we can step out, which is this button. And so stepping out is very simple. All it does is kick us back up to the next level. If we wanted to just use the step over command, we could until we hit a return statement, and then it'll return us back to the normal place without having to click the step out button. So we're going to click the step out, and we are now back up to the top. So now let's talk about the next one, where the continue button. So that's like what looks like a play button, essentially. And so what the continue button is going to do is it's going to let the program resume wherever it was, as if you never started a debugger. And so let's say, okay, we now know FizzBuzz Helper is working. We want to go on to the next level and move on. So let's say we want to see what the next, let's say this for loop is 50 lines long, right? Rather than wait until we get through all the 50 lines by doing step over, we can set a breakpoint and click the continue button, and it will go all the way back around to the next round of the for loop. So the continue button is really useful for that in terms of being able to skip around code very quickly, especially with loops. And if you remove the breakpoint and you hit the continue button, it will run until the debugger finishes executing. So we didn't talk about a couple buttons in this sort of interactive demo, so let's do that. The green button is the restart button. So that also, if you're red-green colorblind, I'm sorry, the sort of like circle with an arrow one, that one is going to reset the debugger and start over as if you had never run the first time. And then this red square is going to stop it in the middle of code execution, so that way you don't have to continue doing anything. So let's take a look at that in our code. So we have FizzBuzz. I'm going to set a breakpoint there, and instead of using the command line, I'm just going to hit run using a key command. And so now you can see we have the debugger. It's telling us this, and if we go, I think it's that one. Yep. Now you can see length is 15. So now we see length is 15. And let's say we want to go here, and then we want to go down there, and let's say we want to go into this vals that depends. So if we click this, you see we've now stepped into FizzBuzz helper when I is equal 0. So now we can go back, there we go, and you can see all of this is happening very quickly, and it's very easy to work with it. So now what we're going to do is we're going to set what's called a conditional breakpoint. So if we say edit breakpoint, and so now what this is going to do is it's basically a breakpoint if statement. So what I can do is I can say I is equal to 15. And so now if I hit the continue button, it's going to run and apparently finish because I forgot that it's not actually going to run through 15. I think I have to go to 16. Yeah, that might work. Okay. And now you can see, yeah, I is 15. So it waits until we hit the correct debugging line. And so now let's debug inside of FizzBuzz helper. So we're going to go inside, and now you can see I is 15. So now what we're expecting is FizzBuzz because it's divisible by 3 and 5. So if I hit next, oh wait, that's weird. It went into Fizz instead of FizzBuzz. And you can realize, oh hey, this is happening because I'm doing and down here, whereas one of the and conditions is already true up there. So what you have to do instead is go and put the and there instead and make this FizzBuzz, maybe, there we go, and make this Fizz. And now if we try that again, we can remove the breakpoints and we run that. You'll see we get FizzBuzz on the last one. So now we know that our code works. And this is really, really useful because when your code gets super duper large, you're going to have a lot of issues where you don't know what variable is holding what, and you've got 15 different variables. So this is a really good idea of when you would want to use a debugger because then you can sort of follow things along very quickly. And so this is arguably better than a print statement debugging. The best time that you would want to use that is for something like a loop that's running 50,000 times. So yeah, that is a debugging tool. And VS Code demo. Our final debugging tool, Professor Google. Google is your best friend. There's no way of getting around that. So let's see a couple of things that have been told to me when I ask people to help me debug something. Google it. I don't know. Have you Googled it? Show me what you found online so far. And so the first two are kind of just non-constructive, just, oh yeah, Google it, figure it out on yourself. But this last one is what's really important because when you ask someone else to help you, it's really helpful for them to get caught up to speed by seeing what you've already done. And it's especially gratifying to know that you're not just being called in because your friend ran into an issue immediately and just called you, right? If you can see what they've done so far and what like debugging steps that they've done, then you know that they didn't just call you the first minute that they ran into an issue. So I'm now going to give us a demo of how to use Google. So let's say you have an error message, right? So let's say I go here and I remove the E there. And if I try and compile this, Python 3 fizzbuzz.py, why is that working? Oh, it's because Python's interpreted. If I remove the equal, that might. There we go. So you're going to get a syntax error of invalid syntax. And so I don't know what this means, right? Syntax error, invalid syntax. What does that mean? Well, let's copy the error message, paste it in this box. So I'm going to put Python syntax error, invalid syntax. I'm going to go over, click Google search, and you're going to get a bunch of results. And so in this case, you're going to see common reasons for syntax error or whatever else. And so generally, when you do this, you're going to come up upon a couple of Stack Overflow posts or some other website, and they'll generally have a good way to at least try and fix your issue. It may not work 100% of the time, but at least it's a good way to test it. So now let's talk about how to use Google when you don't have an error message, right? So let's fix the mistake that I made on purpose there. And let's make this, actually, let's go back to the loop and let's remove all of our is negative code. So now if I run that one again, Python 3 loop.py, and I put a negative number, it's going to give me 0. Why? This is ironic because I'm debugging trying to create a bug. Okay, well, we're just going to pretend this for loop ran or this while loop ran forever because that was what the lecture called for. So you're going to describe your problem. So in this case, you're going to just type out Python while loop running forever, right? You're going to click Google search and you're going to get a bunch of different answers once again. And exactly how to put a bug in your code. And so you're going to get a bunch of different answers. And in this case, this real Python site popped up again, but you're going to see the second one is Stack Overflow. You're going to get a bunch of different answers, but the best ones are typically on Stack Overflow just because it's one of the most popular sites for asking these types of questions. But yeah, so the idea here is when you're stuck, using Google is your best friend. End of story. Just use Google, please. It saves everyone so much time. So now we're going to do a bit of a Google scavenger hunt. And for this, I had to do a bit of a different setup today for the presentation. So instead, I need to swap over my second device here to launch the poll. So poll number 1, that did not work. Okay, let me try that one more time. Okay, well, pollbot is down. Fantastic. So just start spamming your answers in Twitch chat, I guess. We're just going to have to make do with it. So Git is yelling at me. Error, unable to read tree object head. I don't know what that means. Somebody go find it. Let's see what you guys can find out by doing Google searching. And you could take a little bit more time than you'd usually need, but one of these answers is correct, so just start Googling around a little bit. So yeah, it looks like everyone got it. 3 is correct. I have no idea what this command is, but if that's showing the next couple questions. Unable to read tree object at head. So if I Google that, unable to read tree object at head Git, you're going to see the first thing on Stack Overflow is check the output, and then so you want to scroll down because this is the question essentially. If you scroll down, you're going to see here's literally the exact command that you need to do. Perfect. So yeah, this is the first question. Googling is your friend. Next question. I want to echo money sign path, not the current path. So I want literally money sign path. What do I do and how do I get that? And so yeah, feel free to Google again, or if you just happen to know the answer, put that in. Okay, so it looks like everyone got two. That is correct. Sorry for me tuning out there. I was trying to fix bot. Yeah, so two is correct. In this case, it's the backslash there. If we just Google that, echo money sign and bash, or yeah, I'm not sure exactly how you Googled it. I'm going to assume everyone just figured out a good Google phrase. But yeah, basically, in this case, the slash is an escape character, so you're able to just echo, and slash basically says, hey, this usually doesn't do anything, but in this case, let's try it. Also, fixing bot again. Okay, there we go. Thank you, Tim. So let me just create the setup. Okay. So yeah, let's move on to the next one. So the Python compiler is yelling at me. So there you go. So there's the poll question, hopefully, maybe. Nope. Okay, it's in lecture questions. We're going with it because Pollbot is acting up tonight. So yeah, the Python compiler is yelling at me. It's saying this line is wrong. Eval 2 plus 1 times 9 all over 6. What's wrong? Can you help me? You know the answer? I don't know. I don't think this guy's going to be able to help me. It's too bad. I was hoping. I had high hopes for Andy, but he doesn't have any ideas this time. It's all up to you. No pressure, students. Also, apparently bot is still acting up, so yeah, just put it in chat again. Sorry. Okay. Yeah, so 2 is correct. Python eval function must take a string. So if we just do Python eval function, if we Google that, you see evaluate expressions dynamically. If we click on that, you'll see the first argument expression, and it's a string, whereas we've been putting in an expression. So yeah, that's a good example of a very easy thing to debug. Right, I think this is the final one. No, second to last one. So I'm getting an error, io.unsupported operation, not readable, for the code on the right-hand side there. Shrug emoji. Once again, just put it in chat because apparently bot is not having a good day. Okay, so it looks like everyone's putting one in. That is correct. So yeah, one, it needs to be read instead of write. Um, yeah, don't know what to say on that. Pretty simple if you just do IO unsupported operation. Let's try that. IO dot unsupported operation not readable. Boom, first thing, Stack Overflow. You're opening the file using W, which stands for write. You want to read the file, so instead you want to use R. Solved. Yeah. Final one, nothing's being printed. Oh, this is where that question came into play. So nothing's being printed. It just works, but it doesn't actually do anything. Anyone have any ideas? On this one? Can you at least help me out a little bit tonight? Team sport. All right, so it looks like everyone's putting in 3. That is correct. Reverse does not return a new value. Reverse is an interesting function that will basically just do it in place. So it will take in that list and then it will swap it in place. So if I did print my list after doing my list.reverse, that would work. If you want to use reversed, or reverse should be apparently a function, but apparently wasn't, at least when I was compiling it. Not exactly sure why, but if you put 2, I think that also counts. Basically, the reasoning for that is that reverse just happens to be the one that will do it in place. Yeah, and someone put in chat, no need to Google if you already fell victim to this. That is correct. This is something that a lot of people fell for on something. And we saw it a lot in the homework last semester as well, so that's why this question is on here. It's a really good one. But yeah, it's something that a lot of people go through. So yeah, we have just on time, despite our technical difficulties, finished at 7:49. So that was pretty much the lecture for tonight. Sorry for the pollbot issues. We'll probably just end up giving everyone credit for tonight, hopefully. I'll talk it out with Eustace and make an announcement in hashtag announcements and let you know. But otherwise, that's been debugging. I will see you all on Thursday.